The unexpected discovery. Imagine staring into the blackest part of the sky and seeing nothing. That's what astronomers expected when they turned Subaru's massive telescope toward the frozen outskirts of our solar system. But in 2023, a flicker appeared, a faint dot where no dot should be. At first, dismissed as noise. Then it showed up again and again. Month after month, the ghost kept returning. By July 2024, another telescope confirmed it. This wasn't an illusion, it was real. They named it Ammonite, officially catalogued as 2023 KQ14, a world so far away that even Pluto looks like a next-door neighbor. And the more astronomers dug into old data, the stranger it got. This dot had been hiding in plain sight for nearly 20 years. But here's the twist. This lonely speck doesn't just add another rock to the Kuiper belt. No, Ammonite challenges the very idea of Planet 9, and with it, our entire picture of the solar system's edge. Before we unravel what this discovery really means, make sure to subscribe, because the story of Ammonite is just the beginning of a cosmic mystery you won't want to miss. A club with only 4 members. When astronomers traced Ammonite's path, they realized it belonged to one of the rarest groups in astronomy, the Sednoids. Until then, only 3 members existed: Sedna, 2012 VP 113, and Leleaku Honua. Now, Ammonites made 4. Sednoids are cosmic outliers, their orbits so distant from Neptune's influence that they shouldn't even exist. Yet here they are, fossilized clues to the solar system's violent birth. Each one whispers of forces we don't yet understand, footprints left behind by something extraordinary. To test Ammonite's strange journey, astronomers turned to supercomputers at Japan's National Astronomical Observatory. They fed in its orbital data and ran billions of years of simulations. The results? Astonishing. Ammonite has likely followed a stable path for 4.5 billion years, essentially since the birth of the solar system. And yet, there's a catch. Its orbit doesn't match the others in the Sednoid family. It's tilted differently, stretched in its own way, like a rebel refusing to follow the rules. That single detail sends shockwaves through planetary science. If Ammonite is stable and ancient, but doesn't align with the rest, then our models of the outer solar system are incomplete. It's like uncovering a fossil that doesn't fit the evolutionary tree. Do we adjust the theory, or admit we're missing a major piece? For astronomers, Ammonite is both a treasure and a headache, a window into the past, but one that refuses to open cleanly. Ammonite doesn't just orbit far, it orbits absurdly far. At its closest, it creeps within 71 astronomical units of the Sunday. That's 71 times the distance between Earth and the Sun. Pluto, by comparison, averages only 39. At its farthest, Ammonite drifts out to a staggering 432 AU, so distant that sunlight takes 2.5 days just to reach it. And the journey is slow. One orbit takes nearly 4,000 years to complete. Think about that. When the first stones of the Great Pyramid were dragged into place, Ammonite had only just begun the same lap it's finishing today. In other words, a single Ammonite year has outlasted almost all of recorded human history. It's a reminder that while civilizations rise and fall on Earth, the cosmos runs on a timescale so vast that even our greatest monuments are just ticks on its clock. Ammonite's year is a cosmic calendar, one written in patience and distance. The Planet 9 problem. For years, astronomers have chased a phantom, Planet 9, a giant hidden world said to lurk far beyond Neptune, its gravity shaping the orbits of distant objects like a cosmic puppeteer. The idea was bold, even thrilling, another true planet waiting in the dark. But then came Ammonite. On paper, Planet 9 should explain why certain distant bodies are clustered in strange, tilted orbits. Yet Ammonite doesn't fit. Its path refuses to line up with the pattern Planet 9 is supposed to create. In fact, its very existence weakens the case for the hidden planet. Some scientists now argue that maybe Planet 9 never existed at all, that perhaps the outer solar system was sculpted by something else entirely. One theory suggests a massive planet may have once wandered out there, but was eventually ejected, leaving only distorted orbits behind. Another proposes a stellar flyby, a rogue star passing close to our infant solar system, tugging at its fragile outskirts and twisting objects like Ammonite into their current places. Whatever the cause, Ammonite forces astronomers to confront an uncomfortable truth. The outer solar system is more complex and more mysterious than the neat models we've drawn on paper. Maybe Planet 9 is still out there, hiding in deeper darkness than we ever imagined. Or maybe we've been chasing a ghost all along. When stars wander too close. The solar system feels stable. Planets trace their orbits like clockwork, comets flicker in from the cold, and Earth spins through its seasons. But stability is an illusion. Our star is not fixed. It drifts through the Milky Way, weaving among hundreds of billions of others, and sometimes those stars come close, too close. Astronomers calculate that every few 100,000 years, a wandering star may graze the outskirts of our system. Most pass harmlessly, but even a distant encounter can send ripples through the cosmic pond. Their gravity doesn't usually disturb the planets, but it can jostle the Oort cloud, that vast shell of icy debris surrounding us. Millions of silent comets wait out there, and the nudge of a passing star could send some of them plunging inward toward the Sun and Earth. The last known visitor was Schultz's star, a red dwarf that brushed past us around 70,000 years ago. At the time, humans were just beginning to spread across the globe, unaware that a foreign sun had slipped by in the cosmic night. Even closer encounters are possible. Each flyby leaves subtle scars, small gravitational fingerprints that may explain why objects like Ammonite wander so far off course. So when we look at its orbit, maybe we're not seeing the influence of a hidden planet at all. Maybe we're seeing the ancient memory of a stranger that once passed through our neighborhood, a star that bent our solar system and then vanished into the galaxy forever. Some simulations go further, suggesting not just a passing star, but a near miss of staggering proportions. Billions of years ago, a rogue star may have drifted within just 110 astronomical units of the Sunday. To put that in perspective, that's closer than Voyager 1 is today, after nearly half a century of travel. A true cosmic brushstroke. If such a star came that close, the consequences would have been profound. Its gravity could have yanked distant objects into bizarre paths, explaining Sedna's lonely orbit and even the strange retrograde moons around Saturn, Jupiter, and Neptune. These irregular moons, misfits that don't match the neat orbits of their planetary siblings, might not be native at all, but captured refugees, thrown inward during this stellar encounter. Imagine it, two suns rising in Earth's sky, not side by side, but as a trespasser hurtling past in the deep past, invisible to life but unforgettable to physics. One fleeting encounter, and the scars remain etched into the frozen outskirts of our system, in orbits like Ammonites. If true, it would mean our solar system once lived through an event so rare and violent, it reshaped its architecture forever. A silent chapter in our history that no one witnessed yet, its echoes still haunt the edge of the sun's domain. While hunting for Planet 9, astronomers stumbled on something else, something they weren't even looking for. In 2017, they pieced together 7 years of archival data from the Dark Energy Camera in Chile and the Canada-France-Hawaii telescope. Hidden in that data were 19 faint detections of a distant traveler, just enough to reconstruct its path. They named it 2017 OF-201. This object is no ordinary dwarf planet. At its closest, it skims in at 44.5 AU, barely beyond Pluto's reach. But at its farthest, it swings out more than 1,600 AU, an orbit so stretched that it takes 25,000 years to complete a single lap around the Sunday. That's not just far, that's Oort cloud territory, a realm so remote it borders on interstellar space. And here's the strange part. OF-201 isn't even interacting with Neptune, it just drifts, untethered, in its own extreme ellipse. Astronomers estimate it's about 700 kilometers wide, big enough to be spherical, a dwarf planet. But its orbit raises a chilling question. How did it get there? Was it thrown outward by something massive, a hidden planet perhaps? Or was it carved into its path by a cosmic intruder? Whatever the answer, OF-201 is a ghostly reminder that the solar system still keeps secrets buried in its outer darkness. For years, the clustering of distant trans-Neptunian objects seemed like solid evidence that something massive Planet 9 was pulling the strings. Their orbits lined up, tilted and stretched in ways too coincidental to ignore. The pattern pointed to a hidden world 5 to 10 times Earth's mass lurking in the shadows. But then came OF201. Its orbit doesn't just break the pattern, it shatters it. Instead of aligning with the others, it veers off on its own course, a rebel that refuses to follow the supposed gravitational rhythm of Planet 9. Worse still, when scientists ran simulations, they found that if Planet 9 really existed as described, OF201 wouldn't last. Its orbit would unravel in less than 100 million years, flinging it out of the solar system altogether. And yet, there it is, stable, persistent, defiant. So now astronomers face a dilemma. Either OF201 is a bizarre outlier, a cosmic accident we just happened to catch at the right moment, or the entire Planet 9 hypothesis needs to be rewritten. And if OF201 isn't alone, if dozens more like it are hiding in the darkness, then our solar system's edge is stranger, more chaotic, and less understood than anyone imagined. The chase isn't over. So where does this leave us? Two discoveries, Ammonite and OF201, each rewriting the story we thought we knew. One hints at ancient stellar encounters, the other undermines the very foundation of Planet 9. And yet, the search continues. Astronomers haven't given up. Teams are combing through decades of infrared sky surveys, looking for faint dots that shift ever so slightly across the years. The Dark Energy Camera, the James Webb Space Telescope, and soon the Vera C. Rubin Observatory all are being turned toward the deep, cold dark where Planet 9 might still be hiding. If it exists, it may be a world larger than Earth but smaller than Neptune, orbiting 20 times farther out than Neptune itself. Invisible to the eye, faint in reflected light, yet carrying the mass to warp entire orbits. But the truth is slippery. Each new discovery, Ammonite, OF201, forces scientists to ask, are we closing in on Planet 9 or are we chasing shadows? What's certain is this: the edge of our solar system is no quiet frontier. It is alive with mysteries, fossils of ancient chaos, and whispers of things unseen. Maybe Planet 9 is still out there, waiting. Or maybe the real story is even stranger.